lesson is section 8.6, any way you slice it. So to be successful in this section, you are going to have to use your area of a circle formula, which we learned in section 8.5. So make sure you remember area of a circle is equal to pi r squared. Okay, to start this section, we are going to learn 3 new definitions. The first one is for a sector of a circle. I have a picture of it here on the whiteboard. The definition for sector of a circle is the region between 2 radii and an arc of the circle. So it's like a piece of pizza, is the sector. The next definition you're going to have to know for this section is a segment of a circle. Here's a picture of it. The definition is the region between a chord and an arc of a circle. So let's look at that picture for a minute. Notice the center of the circle is marked. You have a chord. Here's your arc. So the area that we're talking about, called the segment of a circle, is between the chord and the arc. It looks like a moon. That's the segment of a circle. And then the last one we're going to talk about is called an annulus. An annulus is the region between 2 concentric circles. So if you remember concentric circles, are circles with the same center Here's a picture of 2 concentric circles. If you were talking about the area between them, you were referring to the annulus. So the definition is the region between 2 concentric circles. Okay, so there's your definitions. The formulas for their areas is what this section is all about. So let's go back to the sector of a circle. And because it's just a little piece of the whole circle, the formula represents that. So the formula for area of a sector is this right here. A over 360 times pi r squared. So what is A? A is the arc length. So we are going to look at an example of that just in a minute after we get through all of the formulas. So the next, make sure you get that into your notes. So you might want to put me on pause. To make sure that you get this into your notes. Remember that this A is the measure of this arc. This is a central angle. So the central angle will equal the measure of the arc. The next formula is for the segment of a circle. This is going to be the hardest one. So if you look at this picture here, you can see that there is a sector of a circle. So if we look at the picture, look at the sector, then you want to subtract out the triangle because we don't want the triangle to be part of the segment. And then what you're left with is the segment. So if I redraw this, there is your sector. We're going to subtract out the triangle, and then that'll leave us with the segment. So we're going to do just that in the formula. So you can see the formula written here. It is A over 360. Again, A is the measure of the arc times pi r squared. So that is the area of your sector. We're going to subtract the area of your triangle, which is 1/2 base times height. And that will equal the area of your segment. So that'll be the most difficult formula that we have. The last one you could probably figure out on your own. You're going to take the area of the big circle minus the area of the little circle to give you the area of the annulus. So here you can see the big circle. Find that area, so that would be this. That would be the area of the whole thing. We're going to subtract out the circle in the middle to be left with the donut or the annulus. So make sure you're getting these formulas into your notes. Area of the big circle minus area of the little circle. So I denote the big circle with big R, radius R. So this is area of the larger circle minus area of the smaller circle. Will give you the area of the annulus. Okay, so let's look at an example of each. So find the area of the shaded sector. So I'm going to put me on pause and work this problem. Okay, so find the area of the shaded sector. Let's see if you got it right. You know, I always want you to write the formula down first. So we just learned that the area of a sector is A over 360 times pi r squared. So in this case, what is our A? Well, because we have a central angle, we know the measure of the intercepted arc will be 45. So 45 over 360 times pi times the radius, which is given to be 20 squared. Now you just have to simplify that. Well, 45 over 360 is 1/8. 20 squared is 400. So 400 divided by 8 is 50 pi. I want you to leave pi in your answers. So your answer should be 50 pi. The next one we're going to look at is the area of the shaded segment. Again, segment. So if you remember, or look back in your notes, for the area of your segment, write the formula down, and then we'll plug in what we know. So the area of a segment we just learned is A over 360 times pi r squared minus 1/2 the base times the height of the triangle. Now, if we look at our picture, this radius is 6, so that means this radius over here is also 6. We have a central angle where the angle is 90, so that means the measure of this arc is also 90. So I'm going to have 90 over 360 times pi times 6 squared for the area of my sector. Then I'm going to subtract out the area of my triangle, which is 1/2 the base, which is 6, and the height, which is 6. So let's simplify that. So 90 over 360 is 1/4. 6 squared is 36, minus 1/2 times 36. So 1/4 of 36 is 9 pi, minus 1/2 of 36, which is 18. In this case, it was centimeters squared. Which reminds me, I forgot to put my units on our area of a sector, so let me go back and add centimeters squared. Remember, that is an important piece. I'm sorry I forgot it. So our answer to the segment is 9 pi minus 18 centimeters squared. And that's how you want to leave your answer. The next example is another area of a sector. This time we're given that the area is 14 pi. So I am going to say 14 pi equals A over 360 times pi r squared. I don't know A. That's what I'm looking for. The radius is 6. So 14 pi equals A over 360 times pi 6 squared. So if we simplify that, 6 squared is 36. I am going to cancel the pi from both, just divide both sides by pi. So I have 14 A over 360 times 36. Well, I can simplify this. 1 here and a 10 there. And then I will multiply both sides by 10. So I get 140 is equal to A. This is degrees, so I'm going to say 140 degrees. So if I look back at my picture, if this arc is 140 degrees, that means X has to be 140 degrees because the central angle equals the measure of the intercepted arc. I'd like to do one more example of finding the area of an annulus. So put me on pause and work this problem. Okay, let's see if you got it correct. Our formula is pi times big R squared minus pi times little r squared. Big R is given to be 8, so it's pi 8 squared. Little r is given to be 2. So we say minus pi times 2 squared. So 8 squared is 64 pi minus 4 pi for an answer of 60 pi units squared. Before you come to class tomorrow, I'd like for you to try a couple of these and I will check them. On page 455, I would like for you to try number 1, number 4, and number 6. One of each kind, and I'll see you in class.